My name is Mathias Timonen. I'm a software engineer at Futurice. I've been working here a couple of years already. Currently doing mostly front-end development, but also full stack development. And I will be talking about DevOps, and I will be talking a bit about what it is, so a bit of theory, and then I will also present how we do DevOps at our client project. So a bit of practice as well. First, I'm going to read this out loud because we have listeners who don't see the presentation. So, brief description of what is DevOps. So, DevOps is a combination of the words development and operations. And it's a software development and delivery process that emphasizes communication and collaboration between product management, product development, and operations professionals. It supports this by automating and monitoring the process of software integration, testing, deployment, and infrastructure changes by establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. And here's a quote from the source there. DevOps is the result of implementing lean principles. So lean principles are about reducing waste and doing the things you need and making things more faster and more reliable and so on, and concentrating on what is valuable. And in a sense, DevOps is sort of a buzzword for good agile, if we talk about software development. But it's a more precise definition of the software development and delivery process than simply agile. Because like we can do agile. Agile is about responding to change, being able to respond to change. And we can do agile, and concepts in DevOps makes that easier. So it makes it easier to do agile in a way. It doesn't matter what, if you do Scrum. People think of it as like, or Scrum is this iterative process with you have sprints, and then you have an increment at the end of each sprint. But you can do still like DevOps, even if you're doing Scrum. People consider DevOps like, well, it's a continuous delivery of value and continuous delivery of new iterations and so on. But you can do that even though you're sort of doing Scrum. And so you can also do Kanban and you can do DevOps. So it's not a problem. Like we in our project we were doing Scrum and we still had these DevOps practices. And now we are not doing Scrum and we still have DevOps practices. So we are doing DevOps anyway. The quote stated that in an environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. So how do you do this? And it's done with continuous integration. This is now a bit more technical. So a push to the source control, it triggers a build. A build triggers automatic tests, and a build package or the code can be statically analyzed for code quality and so on. You can have checks that does this, do we have enough code coverage or do we have any sort of visible technical depth or something like that. And then you can have different source control practices, trunk-based development, feature branches. You can use Git flow, you can have feature toggles, whatever. But it's all part of sort of this continuous integration. You continuously integrate the code into something, something that others are contributing to as well. And then continuous delivery and deployment. So it's then about getting this built package to where it needs to run. So it can be run in the cloud, it can be run on premise or anywhere. And the idea of continuous delivery or deployment is to have as much automated as possible. The difference between these two is that continuous delivery means that you have like all things automated until the push of a button. So to deploy. So when you have the capability of just pushing one button to deploy, then you are having continuous delivery. And continuous deployment is then having this button automated as well. So when you commit changes and push to master or whatever, it automatically gets integrated, tests are run, and the build is complete, and further testing can happen, and then it's deployed to the production environment all the way. Some people and companies are doing this, like even some major companies, like I think Netflix and stuff like this, companies like this. So and there's a lot of literature about which companies do this. So it's about really doing this sort of a way different than historically seen, where you need to build something and you need to prepare for a release and you need to sort of build the release and sort of everything, and it takes months and so on and so on. But the idea of continuous delivery and deployment is that it's really fast. You can do like several deployments a day, so you can do it whenever, and the power can be left solely to the team, or then if you have like continuous delivery, it can be sort of a business decision to do, hey, now we want to do the deployment. And then one thing as well is continuous feedback. So you always need to have continuous feedback when you deploy fast or have the capability to deploy fast, because with continuous feedback you can adjust. And you can make the customer satisfaction increase by listening to the feedback and so on. I wrote a seminar paper when I was in school about the continuous deployment from an end user perspective. So what kind of implications continuous deployment has on the end user user experience. And so let's first, this is a quite busy slide. But if we first look at the blue one, so sorry for those who are not seeing colors, but if the users or stakeholders say, I don't want this and I want that, then if we have a continuous deployment team and a fast cycle, it enables us to build the right product. And then when we sort of fast respond to this change fast, then the stakeholder or end user might be like, cool, this is just what I need. Like they feel that they have been listened to. And also, if we now look at the red one, so this doesn't work. The end users say, or stakeholders say, this doesn't work, that doesn't work. A fast continuous deployment pipeline or process enables us to improve the product quality. So then they are like, hey, we listen to them, then we fix it. Oh, nice, that one bug is fixed, and so on. And then also we can go much faster to the market. So we can, something new happens, some changes can be done quickly to the product. And the users might feel that, hey, no one else can offer me this yet. So it's really, we can actually go faster by just having this continuous deployment pipeline. So DevOps consists of different sort of things, and this is quite common picture. There are various variations of this, but it's if we start from the plan, it's about planning, then creating, so coding, verifying, testing, acceptance testing, so on. Package, so making it ready for release. than actually releasing it, and then configuring whatever needs to be configured depending on the environment, or configuring infrastructure or something like that. And then you monitor. So you monitor what happens in the app, and you monitor what happens in the infrastructure. You monitor how the app is used, and so on. And then it feeds back to the planning. And then this is a loop that continues on growing. And the plan, create, verify, and package, usually sort of related to dev, and ops is then the release, configure, and monitor. And a DevOps team is then able to do all of this. So how do we do it at Fortum Apollo project? So this was just being a public reference, so you can go check out the case description. And so I'm now going to present how we do it in practice at our project. So this is our CI/CD pipeline. Again, quite busy, but let's start from the code level. So we have when we were developing the product, so it was not yet in production. We had this source control practice of feature branches, and every commit to dev, so a branch, is automatically built and then automatically deployed to the dev environment. So we have our code resides in GitHub, and we have TeamCity to create the builds, run the CI, the tests, and so on. And it gets the latest commit by polling, and then it sends it to deployment through Octopus deploy, and there we configure some environmental variables and so on, so that, hey, this is a dev environment, use these URLs to address, to reach this database and so on. So different stuff. And if we then, so then we have different environments. We have dev, test, staging, and production. And always when we merge to master, we had a build configuration in TeamCity that automatically pulls the master branch. So then it builds, runs a test, and so on, and then automatically pushes to test and staging. This was okay at the time when we were still developing it, and we still had a manual trigger for deploying to production. Well, basically the PO was testing in production, and we just had different kind of environments, and the sort of the non-dev build then deployed to test and staging, so that we could test if it still works there and so on. But yeah, this was like fairly easy in the development phase. Then when we went to production, we want to have a bit more control. So then we just changed the way how we handle our source control. And we do that now with a well-established sort of practice called Git flow. And it basically has the same sort of feature branch idea there as well. But when you want a new version into other environments than dev, you create a release branch. So basically you want to create a release, and you want to sort of get that into production at some point. You create a release branch, and that is then, instead of master, you create a release branch, and then that is automatically then built and deployed to testing environment. And then we do some testing there, and the developers still do testing there, and then we have a manual deployment to staging, because the PO does acceptance testing there. And then when all is accepted, no immediate errors, or like the system works as it's supposed to, then we can deploy to production when it suits the business. So we don't want to have continuous deployment, because sort of it really depends when you do deployments, and it disturbs the work if you do deployments like at certain times. But it's just our app. Some other apps might not take any damage at all if you deploy often. It totally depends on what is the sort of business need and what is the application for. In my literature review, which I did in 2006, the seminar paper I talked about, they're usually the environment where we want to have control, or for instance, telecommunications and really sort of business critical systems where if something sort of it really disturbs the business if a deployment happens. So in telecommunications, quite many places still have this sort of hard way to create new releases and so on. But they are also going towards this continuous deployment. I used to work in telecommunications like 4 years ago, and it definitely probably has changed by now. So yeah, don't listen to me regarding that. But yeah, so this is our a bit about the Git flow again. So when the release candidate has gone through staging and it has been deployed to production, then we merge it to master. And why do we do it then? And what purpose does master serve? It serves as the current production version, so that if we need to do a hotfix that doesn't have the baggage of what is in the dev environment. Because previously we had some issues when we were still developing that, okay, some issue has gone all the way to production. The PO was testing still in production. So then we just, okay, well, here comes a bunch of other things that are not completely tested, but here's the hotfix as well, and so on and so on. Of course, you can do this by sort of checking out the previous commit or so on, but then it becomes a hassle and sort of you really have to know what you are doing. But this is a well documented and sort of fairly easy to understand way how to manage your versions. And so you can do a hotfix straight to the production by just checking out from the master branch, creating a hotfix branch, and that is then deployed all the way to testing if everything goes well, and then to staging and production if the further testing goes well. Then we have Jira. Yes, you have a question.
What's SonarQube?
Ooh, sorry, I forgot to mention that. So, yeah, this is now included as well. So we have static code analysis on SonarQube. So it can say that, hey, we can have sort of these restrictions that, hey, fail the build if the test coverage isn't above 80% or something like that. So it analyzes the code and it says that, hey, here you have duplicate code, or this thing is never gone through, and then this is a stupid if-else statement or something like it points out that, hey, and it really, you can choose to make it affect your build or CD pipeline. Currently on backend it has some kind of effect, I think. On front end it doesn't. So it just shows that, hey, this is now the state of your code. You can take it or leave it. And then I choose that, okay, I think this is an important issue. And then it helps me. It has helped me uncover some bugs at times. So it's an added benefit. Why shouldn't you use it? You can choose if it has control of your workflow or not. You can decide. It's your project. So yeah, and we use Jira for configuring or planning and having our requirements. This is just our software issue workflow. So story or bug goes through, progress is resolved, and in test and ready for testing. It can be accepted, rejected, then deployed to production and closed. And this is just to be able to see where stuff resides and what happens, what comes next, and so on. You don't have to use Jira, but if you use Jira, you should use it properly. And then now we are trying to use it properly, and it actually helps us. Some people might think, well, it's too heavy. Well, okay, then you can use Trello or something else. Like, if it makes sense to you, or if it doesn't, like choose based on that. For us, it's and stakeholders, it's important to see where work is ongoing and so on. And then we are following this. We are configuring Jira to best represent the state of our development. And we also have task workflow for tasks, something that is not related to code. So, for instance, some CI configurations or CD configurations or other things to do, which are not related to code. Incident workflow, something has happened, we don't know why, we need to investigate it, and then we can create either a feature, ticket, or story, or a bug fix based on the incident. So here we document what has happened, what's the resolution, and so on. It's important to have these also documented in our software. Some software don't need to do it. Then we also have feedback workflow. This is the latest feature. I implemented a feedback button in the UI, so that the users can directly, by clicking the heart on the top right corner, they can give directly feedback, and it goes directly to Jira. And so PO can go through them and see, hey, this is a really good thing, and then we can address it, and then we can prioritize it and work on it. And then we have Elastic Stack. So the ELK stack. ELK stands for Elasticsearch, Logstash, and Kibana. So we use it for logs and monitoring and alerting and sort of seeing what happens in our application, our infrastructure, and being able to find out the root causes of something. So Logstash is a way to collect and transform logs, and so it can be business logs or just application logs. Elasticsearch is for searching and analyzing these logs, so it's basically a database where it's really fast, and then you get like results really fast. And Kibana is then the user interface to visualize and manage these sort of logs and whatnot. And then we also have APM, so application performance monitoring. It also goes then through Elasticsearch, and you can view them through Kibana. And then we have monitoring, so that we can see how the infrastructure is doing. And then we have alerting for some things that if some things go wrong, then we know about them without getting the information from the end users. So we can address certain issues quite fast without needing to get a call from the PO that, hey, this doesn't work, so we can see it. Is this DevOps only technical stuff? Well, short answer and also the only answer is no. It's not only technical stuff. So I quote again, DevOps encourage culture changes and emphasize the followings. So empowerment, accountability, and teamwork. The team that is building the product really needs to have the power to do all the changes. So they need to be able to deploy to the environment or configure the infrastructure or at least work together with someone who knows how to configure the infrastructure, and then the team has accountability because they have the power. And so it's not like, hey, this is not my job. It's more like, okay, can I do something to help you fix this, or can we resolve this together, or if something happens. And teamwork. You need to be able to work in a team, because one person can't do everything, or they can, but they might not have the time to do everything in a timely fashion. So you need to be able to collaborate with different people with different disciplines and competences and so on. And if the team who is building the product doesn't have sort of the power or these things, it's really hard to make DevOps work. And DevOps also takes time to do and prepare. So when to do what? When you're developing, it really depends on what you are building and how fast you need to get it live into production. So if you are building a prototype, maybe you don't need to set up a CI/CD pipeline and all this monitoring and alerts and so on. It's just a prototype. Just smash it together, see it, and then, okay, this was the thing. Then you scrap it and build it again, but with good software development practices in mind and sort of building these continuous integration and deployment pipelines as well. So a good CI/CD pipeline speeds up development in the long run. In the short run, it takes time. But really, if you know that this is the thing that we are going to build, then you build it properly. Then you put the CI/CD pipeline there so that you can actually adapt changes faster. So you can go faster, respond to market change faster, implement features faster, more reliably, and so on. Good software development practices and various testing and quality assurance approaches are crucial for avoiding technical debt and going fast. So if we have a lot of technical debt, it's not easy to change things. So you also need to have these sort of tests that you do and good software development practices, perhaps code reviews, pull requests, and so on. And this is also integral into having a good sort of DevOps process. And when going to production, think about how you want to do releases. Do you want the continuous deployment, so everything is automated, or do you need some kind of control? And what do you need to inform? What do you need to do? And sort of think about it. It matters. And when things go wrong, it's nice to have logs, metrics, and alerts, because then you can resolve things and study things faster. We didn't used to have it when we developed, and it took a lot of time at times to figure out what went wrong and so on. Now it's easier because we have logs of everything. We have metrics to show that, hey, this thing was at the max when we encountered this error and so on. And then we can configure the infrastructure and environment to cope with that in the future. And when shit really hits the fan, you want to know how you can roll back. So, yeah, and do practice that before you actually go into production. So have a process of hey, this actually didn't work, it broke everything, then previous release, everything, and now it works again. So practice that. We practiced it like 3-4 times and failed 3-4 times, and then we succeeded, and then we were able to go into production. So really practice this, because it might not be as easy as you think it is. And here's some further reading from Futurice people. The first one is from Mika Rokonen, and Holistic DevOps blog posts are from Paavo Punkari and Jori Mäkkeli. Yes. Thank you. That's it. Any questions?
Hi, thanks for the presentation. I was wondering about selling this to the client. Like if you happen to have a client that doesn't really, I don't know, is maybe a bit old school.
Yeah.
How do you sell this? Because it usually requires quite a bit of upfront investment with the promise of then going faster in the future. Have you found that easy to communicate to clients?
No. Yes and no. I know the arguments that you need to use. I've written it down on a sort of blog draft. I intend to publish it at some point, perhaps, hopefully. But you really need to sort of make them understand what are the consequences in which kind of situation, like technical debt. Something happens. Of course, like if they don't know what technical debt is, then you need to explain and how it can occur. Give, for instance, an example of some really critical thing that was due to some technical debt, and sort of make them realize that, hey, this can happen, and then it can take this long to get up or fix it, and this can be the implications, and this can be the cost. So you really you sort of need to be a really good consultant in a way to be able to convince the client that, hey, this can happen, this is the risk, and so on. But of course, it's a decision that the product owner in the end probably makes. Like if the most important thing is to get to the market really fast, because otherwise you are out of business, then you can think of sort of taking a bit technical debt perhaps now and then. But otherwise, you should always try to minimize technical debt, do things properly, because, well, you will make life miserable for end users, for the product owner, for the business, for the money, for the future developers. There are arguments for each of these. You need to find them out and find a way how you present this to your client so that you are heard. And yeah, it doesn't hurt to write things down and prepare or train or practice. I don't know. That's my tip. I don't have an absolute answer, but that's my tip.
That's a good answer. Thank you.
Yeah, thanks.